The next context is the angular quantities. In particle mechanics, you dealt with quantities of linear motion, like linear displacement, linear position, linear displacement, linear velocity, and linear acceleration. Similarly, in this section, we will deal with angular position, angular displacement, angular velocity, and angular acceleration as vector quantities. This is linear position, this is angular position. Angular position. This is analogous to linear position in particle mechanics. This is linear displacement. This is angular displacement. This is analogous to linear displacement. This is angular velocity, which is analogous to linear velocity, everybody knows. This is angular acceleration, and this is analogous to the linear acceleration. These quantities define the kinematics of linear motion. These quantities define the quantities of, or the motion of, or the kinematics of angular motion of rigid body. This can also be used to define the kinematics of linear motion of rigid body. Combiningly, the motion of a rigid object can be explained by these angular quantities. So also, or in addition to the linear quantities, what we discussed in the particle mechanics. Any rigid object is a system of particles which are very closely held or spaced such that because of very strong intermolecular attraction, this object cannot be twisted, cannot be deformed, cannot be compressed, cannot be elongated significantly under the action of a considerable force and torque that I explained you. When you consider the center of mass of the system of particles, either you can take each atom or each molecule as particle, or you can take a small segment or small element or elementary segment of this rigid body as particle. This will be the center of mass of the system of particle or center of mass of the rigid body. The center of mass may move with some velocity, linear velocity, because center of mass is a point. For this point, we can give all these quantities. This point may have some position characterized by a position vector, or it can have some velocity vector, it can have some acceleration vector, and it may undergo some displacement also. S can be written as del R, as you know, in particle kinematics. So, when the rigid body moves, it can have the linear motion. When it has the velocity, linear velocity of the center of mass, we call it a linear motion, and when the rigid body undergoes an angular motion, it must have angular velocity. So, the entire motion of a rigid body is characterized by the angular velocity and linear velocity. The motion of rigid body is characterized by linear velocity of center of mass and angular velocity. Both linear velocity of the center of mass and angular velocity of the rigid body, that is what I am going to tell you in this section. Combiningly define the kinematics of rigid body. But since center of mass is a point, the point has the position as the displacement, it can undergo displacement, it can have velocity, it can have acceleration. Therefore, all these things you have read in particle mechanics. So, the new thing for you is the angular quantities. Are the angular quantities, the angular position, the angular displacement, the angular velocity, and the angular acceleration. One by one I am going to tell you in this section. Combiningly, this two set of quantities, angular quantities and linear quantities as a whole will describe the motion of a rigid object or the rigid body. A rigid body therefore has two types of motion. Motion number one, angular motion. Motion number two, the linear motion.